Okay, so get ready for this. We are diving into the world of intelligence, but not the kind, that you'd find in a textbook.
Right.
Think fungi, slime molds,
Yeah.
Organisms that exhibit behaviors that you wouldn't expect.
Yeah.
It's going to make us kind of rethink what it means to be intelligent.
Yeah, it's pretty fascinating. We tend to always link intelligence to, having this complex brain and everything. But these organisms, they challenge that notion.
Yeah.
And really showcase how diverse intelligence could be in nature, how many forms it could take.
Exactly. So, like, for example, let's take Phanerocata velutina.
Mm-hmm.
It was featured in one of these articles. And this fungus, it displays some, pretty impressive decision-making skills, especially when presented with different arrangements of wood blocks.
Right. So researchers in Japan, they actually set up this experiment where they took these wood blocks and arranged them in, shapes, so like crosses, circles, things like that.
Okay.
They wanted to see how the P. velutina mycelium, which is kind of like its root system,
Would interact with these different shapes.
So what happened? Did it just, treat it like an all-you-can-eat buffet, or?
Not at all.
Mm.
The way the mycelium spread seemed very deliberate. So, for example, with the cross shape, it went for the outer blocks first, almost as if it was, mapping out the overall pattern.
Oh, wow.
And then with the circle, it actually completely avoided the center as if it knew there was nothing there.
Huh.
So it's like recognizing shapes. It's like processing information.
Yeah.
And then it's making decisions based on that information.
Right, exactly. And the researchers, they were stunned. They even went as far to say that, the mycelium demonstrates memories, it can learn, and it can make decisions.
Wow.
Which is quite a statement when you're talking about a fungus.
Yeah, that's pretty wild. But how does this even work without a brain?
Yeah, that's the real mystery. Fungi, they don't have brains or nerve systems like we do. They function on a whole different biological principle. And this kind of leads us to think that, well, maybe there are other ways of processing information and solving problems, ways that, we're just starting to uncover.
Yeah. So we're underestimating what other life forms are capable of?
Mm-hmm.
Could there be different types of intelligence out there that we haven't even considered?
I think so.
Yeah.
Speaking of alternative ways of thinking, another article explores living computers.
Oh.
Created from human brain organoids.
Okay, now that sounds straight out of a sci-fi movie. What are we talking about here?
So basically, imagine mini brains grown in a lab. These are called organoids. And scientists are connecting these to electrodes to create biological computers. And there's actually a company called Final Spark that's leading the way in this research.
Wow. So we're essentially building computers out of brain cells.
Mm.
But why? Don't we have perfectly good computers already?
Right. Well, it's about energy efficiency. Traditional computers, even the most advanced ones, they're really energy hogs compared to biological systems.
Yeah.
Think about it. Your brain can perform all these incredibly complex tasks and using far less energy than a light bulb.
That's a really good point. I
Yeah.
hadn't thought about it that way. So are you saying these organoid computers could be the key to a more sustainable computing future?
Well, the potential's there. The article highlights that living neurons can use over 1 million times less energy than the current, digital processors we use.
Wow.
So if we could harness that kind of efficiency, imagine the impact on, technology, the environment.
It's huge.
Yeah.
It seems like both the fungus and these brain organoid examples point to totally different ways of processing information and solving problems. It's almost like seeing different styles of intelligence at work.
You hit the nail on the head. It kind of begs the question, what exactly is intelligence? How do we define it, when we're seeing such diverse examples of problem solving in nature?
Right, exactly. Because it's not just about being good at math or writing poems or whatever. It seems like there's a whole spectrum of intelligence out there.
Yeah, and one of the sources we have, Theories of Intelligence and Psychology, it actually points out there isn't a single universally agreed upon definition of intelligence.
Really?
Even the experts are still debating this.
Wow. So we're diving into uncharted territory here. I'm even more intrigued now.
What's interesting is that while there's no single definition, some common themes do emerge.
Yeah.
Things like, the ability to learn from experience, recognize when there's a problem, and then come up with a solution.
Right.
It's like these are the foundational elements of intelligence, regardless of, how different minds approach them.
It's like A universal language of intelligence, but
Mm-mm.
with different dialects or something like that.
Right.
But let's circle back to those brainless wonders we were talking about earlier. I mean, if a fungus can solve problems without a brain, does that mean it's intelligent?
Hmm. It definitely makes us rethink our assumptions.
Yeah.
To explore this further, let's dive into the world of slime molds,
Okay.
particularly Physarum polycephalum.
Okay, here's where it gets really wild. Tell me more about this slime mold.
So Physarum polycephalum, it's a single-celled organism, but don't let that fool you.
Okay.
It contains millions of nuclei, and it has this incredible ability to change shape. So imagine like a single cell acting as a whole organism, constantly adapting, evolving.
Okay, that's already pretty impressive.
Mm-hmm.
But what does this have to do with intelligence?
Okay, well, get this. P. polycephalum can solve mazes. Researchers put them in mazes, food at the end, and they actually figure out the shortest path. They retract from dead ends, optimize their route, and all without a brain or nervous system.
Wait, hold on. A single-celled organism is solving mazes.
Right.
How is that even possible?
It suggests that, problem-solving abilities can come from networks, even without like a central brain calling the shots, and they go beyond mazes.
Okay.
In another study, they actually placed food sources in a pattern that mimicked the Tokyo railway system,
Uh-huh.
and you won't believe what happened next.
Let me guess. The slime mold recreated the train lines.
Exactly. P. polycephalum spread out, conducted the food sources in a network that actually mirrored the Tokyo railway, finding, the most efficient routes, just like human engineers would.
That's incredible. It makes you wonder what intelligence really means if a slime mold can do something like that.
Yeah.
What other surprises do these slime molds have in store for us?
Oh, plenty. It turns out they have another trick up their sleeve, navigating time.
What?
Yeah, they seem to have these internal clocks that
Yeah.
allow them to, anticipate changes in their environment.
Time travelers. Okay, you're really blowing my mind now.
So think of it like this. In one experiment, researchers repeatedly exposed the slime mold to unfavorable conditions,
Uh-huh.
like low humidity at regular intervals.
Okay.
And what they observed was fascinating.
Did it, learn to expect those changes or adapt somehow?
Exactly. Even when the conditions were no longer being changed, the slime mold would slow down at those same intervals,
Ah.
as if anticipating those unfavorable conditions,
Wow.
even though they weren't happening anymore.
It's like having, a sixth sense for time.
Right.
It's almost like they're predicting the future. So they can solve mazes, create complex networks, and now they have a sense of time. Is there anything these slime molds can't do?
Well, there is one thing. They're incredibly picky eaters.
Oh, okay.
Studies show that when given different food choices with, varying nutrient ratios, they'll consistently choose the food with the optimal balance for their survival.
So they're not just brilliant, they're health conscious too.
Exactly.
These slime molds are putting us to shame. But, these incredible abilities, especially the time navigating one, it makes you wonder, could these organisms be conscious?
Ugh, that's the million-dollar question, isn't it? And it brings us to this really thought-provoking article titled, "What is Consciousness?" And, it sheds light on this complex phenomenon and some of the challenges in understanding it.
Yeah, I've been pondering this throughout our whole discussion today. If these organisms can solve problems, make decisions, even anticipate the future in their own way,
Mm-hmm.
could they have a level of awareness? I don't know.
It's a question that has fascinated, scientists and philosophers for ages.
Right.
The article introduces this concept called neuronal correlates of consciousness, NCCs for short.
NCC.
And I think of them as the minimal neural mechanisms in the brain necessary for any conscious experience.
Okay, so for me to feel, say, a headache,
Mm-hmm.
there needs to be specific neural activity occurring in my brain.
That's the gist of it. But here's the catch. Not all neural tissue results in consciousness.
Okay.
For example, the spinal cord, billions of neurons, right? But if it's completely severed, a person loses, sensation and control below the injury,
Right.
but they don't lose consciousness.
So while the spinal cord is crucial for a lot of functions, it doesn't seem to be directly involved in generating a conscious experience.
Precisely. Another example is the cerebellum, packed with even more neurons than the rest of the brain combined.
Wow.
And it's essential for, coordination, movement, but damage to it doesn't seem to impact consciousness either.
Huh. So the number of neurons alone doesn't doesn't determine consciousness. There must be something more to it.
Yeah.
What are researchers saying about this?
Well, they're trying to pinpoint the specific mechanisms involved.
Okay.
And the article suggests that a region of the cerebral cortex called the posterior hot zone
Okay.
could be key. It seems to be crucial for generating conscious perception.
The posterior hot zone. So I'm picturing like a control center for consciousness in my head. What makes scientists think this area is so important?
Well, studies using binocular rivalry.
Mm.
So remember we were discussing those images, the alternating Donald Trump and Hillary Clinton.
Yeah. That was pretty wild. How does that relate to this hot zone?
Well, when researchers monitor brain activity during binocular rivalry, they see a lot of activity in this posterior hot zone.
Oh, interesting.
It seems to be working hard to resolve the conflicting information coming from, broke eyes.
So it's like this area is trying to make sense of what we're seeing, even when it's like confusing or ambiguous.
Exactly, and there's more. When scientists electrically stimulate parts of the posterior hot zone, they can actually trigger specific conscious experiences in people. Things like, flashes of light, geometric shapes,
Oh, wow.
even feelings of familiarity or unreality.
That's incredible. It's like they're directly accessing and activating conscious experiences.
Yeah.
But this brings us back to the fungi and slime molds. I mean, they don't have a cerebral cortex,
Right.
let alone this posterior hot zone.
That's the heart of the puzzle, right?
Yeah.
If this complex structure of the posterior hot zone is so essential for, our consciousness, could there be completely different mechanisms at play in organisms that don't have brains like ours?
Could there be like different ways to achieve consciousness, like
Hmm.
pathways we haven't even begun to understand?
It's a mind-boggling thought.
Yeah, it really is. I mean, it challenges our current understanding and suggests there might be more to consciousness than we currently realize. We tend to define it based on our own human experiences,
Mm-hmm.
which might not be applicable to organisms with, vastly different biological structures.
Are we using the right measuring stick?
Right. Could there be different like flavors of consciousness, just like we're seeing different expressions of intelligence?
That's a very intriguing point. It's like we're trying to understand a foreign language using our own grammar rules.
Yeah.
And, our understanding of consciousness is still in its early stages. And we need to be open to the possibility that it manifests in ways beyond our current grasp.
So how do we even begin to study consciousness
Yeah.
in organisms that don't have brains like ours? I mean, where do we go from here?
That's the million-dollar question that researchers are grappling with, and they're exploring various approaches, such as looking for patterns of electrical activity or chemical signaling within these organisms that correlate with their behavior. It's like trying to decipher a hidden code.
It sounds like we need entirely new tools and ways of thinking to even approach this question.
It requires a shift in perspective.
Yeah.
We need to move beyond our human-centric view of the world and consider that that consciousness might exist in forms we haven't even imagined.
It's a humbling thought, but also incredibly exciting. I mean, who knows what secrets these organisms might hold about the nature of consciousness itself?
Yeah.
This reminds me of something else the article touched upon, this idea of a consciousness meter.
Oh, yes.
Like a device.
That's a fascinating concept. The article highlights the need for a reliable device
Right.
that could accurately detect the presence or absence of consciousness,
Right.
especially in individuals who can't communicate.
Yeah, I can see how valuable that would be,
Yeah.
helping us understand and care for people with severe brain injuries or those in a coma.
Mm-hmm.
I mean, imagine the possibilities.
The implications are profound.
Yeah.
It could revolutionize how we treat consciousness disorders, inform ethical debates about, end-of-life care. And who knows, maybe someday it could even be used to assess consciousness in other life forms.
Now, that's a thought-provoking idea.
Right.
If we could develop a device sensitive enough to, like, detect different forms of consciousness beyond our human understanding, it would open up a whole new realm of exploration. We could study the diversity of minds on our planet and beyond.
It would be a paradigm shift in our understanding of consciousness, driven by these remarkable discoveries in the natural world.
It truly is a fascinating time to be studying these questions. We've covered a lot of ground today, from the problem-solving abilities of fungi and slime molds to the complexities of defining intelligence and the profound mystery of consciousness. It's been an incredible journey.
It has been quite the deep dive, hasn't it? And it all points to a fundamental realization
What's that? What's like the one thing you hope our listener takes away from all of this?
that we've encountered astonishing problem-solving, adaptation, and what appears to be decision-making in organisms that lack brains as we know them. And it makes you wonder, what other incredible abilities are we overlooking in the natural world?
You're right. It's like our textbook definitions of intelligence went out the window the moment we started looking at these fungi and slime molds. And the possibility that they might even possess some form of consciousness, despite not having brains like ours. It really challenges our assumptions about the nature of life itself. So what's next? Where do we go from here?
Yeah.
Feels like we're at the edge of a scientific revolution.
Yeah, I agree. I think these discoveries, they really challenge our preconceived notions about what intelligence is and what consciousness is.
Yeah. They force us to question whether our current definitions are too narrow, too
Yeah.
focused on ourselves.
Right. Maybe these organisms demonstrate alternative paths to awareness,
Yeah.
ways of experiencing the world that we're only, beginning to grasp.
It makes you wonder if we're missing something fundamental about life itself.
Hmm.
Maybe intelligence and consciousness aren't limited to brains as we know them,
Right.
but are more widespread and diverse than we ever imagined.
Yeah, that's a profound thought. If we open ourselves to the possibility that intelligence and consciousness exists in forms beyond our current understanding,
Yeah.
it could completely change how we view, biology, evolution, even our place in the universe.
It's both humbling and exhilarating. Imagine the possibilities if we could like tap into these alternative forms of intelligence, learn from organisms that have thrived for millions of years,
Hmm.
often longer than we have.
The potential is immense. Think about, the breakthroughs we could see in fields like computing, robotics, even medicine.
Yeah.
And on a deeper level, it could, reshape our understanding of sentience, the very essence of being.
It's like we've stumbled upon a hidden dimension of intelligence and awareness right here on our own planet.
Right.
What other secrets is nature holding back?
I think the study of, these seemingly simple organisms like fungi and slime molds
Right.
might hold the key to unlocking some of life's most profound mysteries.
This deep dive has been a mind-expanding experience.
It has.
It's challenged my assumptions, broadened my perspective, and left me with way more questions than answers.
Well, that's the beauty of true learning. It's not about, reaching definitive conclusions, but embracing the ongoing process of discovery, questioning and expanding our understanding of the world and ourselves.
So, as we wrap up this incredible journey into the realm of brainless brilliance,
Mm-hmm.
what's the one takeaway you want our listener to ponder? What thought will keep them curious and engaged?
I would say the next time you see a patch of fungus or slime mold,
Yeah.
take a moment to appreciate the hidden complexity, the potential intelligence, and even consciousness within these seemingly simple organisms.
Yeah.
They may hold the keys to understanding some of life's greatest mysteries.
Beautifully put. We'll leave our listener with this final thought-provoking question. Could there be different flavors of consciousness, beyond human comprehension, existing right under our noses in the natural world? It's something to contemplate as we continue exploring the incredible diversity of life and the mysteries of the mind.